Okay, now we are going to start working examples where we need to calculate things. Now let's start with this first one. A 20 kilogram mass has an acceleration of 3 meters per second squared. What is the net force? Okay, net force is ma. So that's easy. So 20 kilograms times 3 meters per second squared. So in this case, that's 60 kilogram meter per second squared. That is 60 newtons. Okay, wonderful. That's an easy question. Okay, next. Ashley is pushing a 50 kilogram mass with a force of 100 newtons, while Jerry is pushing it with 70 newtons in the opposite direction. What is the acceleration of the mass? Okay, here it's a little more complicated. So we have a 50 kilogram mass, and then we have Ashley pushing it this way with 100 newtons. So F Ashley is 100 newtons, and then Jerry is pushing it this way, Fg. Okay, let me write the full Jerry so we'll not confuse it with the gravitational force, 70 newtons, and then of course we have the gravitational force Fg, which we can find. We don't need to find it in here, but m times g, and we have the normal force. Now the only forces along the horizontal are Fa and Fj. The only forces along the vertical are Fn and Fg. We don't have an acceleration up or down, so these two must be balanced and we will not have to worry about them. We are left with the other two. Now that means Fa plus Fj is equal to ma. Now here the forces are along different directions, so I have to figure out a way of handling that. The way to handle it is to choose one of the directions as the positive direction. For example, if we choose this direction as positive, then my Fa is going to be plus 100 newtons, my Fj is going to be minus 70 newtons, and that should be equal to my m, the 50 kilograms, times the a that I'm looking for. Now 100 minus 70, that gives us 30 newtons, is equal to 50 kilograms times a. So solving for a, so it's 30 newtons over 50 kilograms, dividing both sides by 50 kilograms. So it is 3/5 of meters per second squared, or newtons per kilogram. 3/5, it is 0.6 meters per second squared. Okay, let's try another one. Okay, this is even a little more complicated. What force is needed to accelerate a sprinter from rest to a speed of 10 meters per second in half a second? So we have several things given. This is probably going to be more complicated than any homework problem that I will give you. If I give you something like this in a test, it will be broken down. What is the acceleration and then what is the force? Now, but here, since I'm the one working it, I can handle it. So what we have here, the mass of the sprinter from rest, that's initial velocity, and then 10 meters per second, that gives us the final velocity. And we are given a time, half a second. Okay, now the force needed, the unbalanced force, is going to be MA. So I'm going to need to find A. I'm going to find it using kinematic equations where A is VF minus VI over T. In this case, that's going to be 10 meters per second minus 0 over 0.5 seconds. So it's going to be 10 meters per second over 0.5 seconds. That will give us 20 meters per second squared. That's quite a huge acceleration. So F is going to be 75 kilograms times 20 meters per second squared. So that's 1,500 newtons. Okay, let's try another one. This is also the same level as the other one, and it can be broken into several questions. Okay, now first question can be, so we have a bucket. At the end of a rope, and it is being lifted upward with an acceleration of 4 meters per second squared. The question is, what force must be exerted by the rope? So what are the other forces acting on the bucket? Okay, there is the force of the rope, let's call it Fr, the gravitational force Fg, and that's it. Since it's not touching any surface, there will be no friction, no normal force. That's all what we have. Now, to be able to find the force of the rope, we might need to find F sub g first. Okay. Now, look at what we have here. Fr along the vertical, Fg along the vertical, but they are in opposite directions. They don't fully balance each other out. That's why we have an acceleration of 4 meters per second squared. Now, if I take the upward direction as positive, then what are we going to get? Number Fr plus Fg is equal to m times A. In this case, our unknown Fr and Fg is going to be a negative number that we'll find in a little bit since the upward direction is positive, and that's equal to 20 kilograms times A. A is positive since it's in the upward direction. It's 4 meters per second squared. So to find Fr, I need to find Fg. So what's Fg? That's easy. Fg, it's m times g. So in this case, that's going to be 20 kilograms times minus 10 meters per second squared. The direction, remember. So it is minus 200 newtons. So I'm going to go back to the top equation. Fr, instead of plus Fg now, it's going to be minus 200 newtons. And it's going to be equal, instead of 20 times 4, I'm going to calculate it. That's going to be equal to 80 newtons. So solving for Fr, I'm going to add 200 newtons to both sides. So I end up getting Fr equal to 280 newtons. Okay. So it's a little, again, as complicated as it can get for this level course, but it's something we can handle. But remember, I will not ask you, if I'm going to ask you a question like this on a test, I'll break it into sections.